Guys, welcome back to TechDose, and in this video we will look at minimum limit of balls in a bag problem, which is from Leetcode number 1760. Let's now look at the problem statement. In this problem you are given an integer array nums where the ith bag contains nums i number of balls. You are also given an integer max operations. You can perform the following operation at most max operations times. Take any bag of balls and divide it into two new bags with a positive number of balls. For example, a bag of 5 balls can become two new bags of 1 and 4 balls, or you can also form two new bags with the size of 2 and 3 balls. Your penalty is the maximum number of balls in the bag. You want to minimize your penalty after all the operations. Return the minimum possible penalty after performing the operations. Before looking at an example, let's look at the constraint. In this case, you will find that the nums length is less than equals to 10 to the power of 5. And the max operations and each of the nums value will be within the integer range. Let's now look at some examples for better understanding. In this case, let's assume that an array 8, 3 is given and the max operations is 2. Now let me explain you the operation one by one. Take a bag and divide it into two bags. Okay. The division can be unequal, so you are not just required to divide it into two halves equally, but it can be unequal and you can do any kind of distribution you like. But if you are choosing to divide a bag, then definitely you will put at least one element in one of the bag, right? We need to do it for less than equals to max number of operations. So even though the max operations are mentioned as 2, we can do 0 times or 1 time or 2 times. So it does not mean that we will be using all the operations, but we should not exceed this number of operations. Okay. After all the operations are done, the cost will be equals to the maximum balls in a bag. So after the entire division, we can just iterate through the entire list and get the maximum value and return it. So we need to minimize this cost. If you look at this example, array A where we have 8, 3 and the max operations allowed are 2. Then we can choose any of these element and try to do a division. Now if you want to minimize the max value in this array, then definitely I will be picking this 8, and let's say that I divided it into two parts. So here I have used one operation. After having done this, let's pick the next maximum again, which is 4, and divide it into two parts. So I will make 2 again and the rest 4, 3. After doing these two operations, I cannot do more operations, right? Because the max was 2. What is the maximum balls in a bag? So there are 4 bags now and the maximum balls are 4. Therefore the answer in this case is 4 in this kind of division that we have done. But this is not the only way that we can divide. We can also divide this 8 into, let's say, 6, 2 and leave the 3 as it is. And after this we can apply the second operation where I will divide this 6 into two parts, this 3 and 3, and the rest 2 and 3 will remain as it is. Now after having done these two operations, we will be finding the max size of the bag. So it will be 3, and so the answer in this case is 3. So we have to try all these possibilities, and if you try all these possibilities, then one of them will definitely give you the minimized max value, and that will be your result. So in this case the answer is 3. You can try out all possibilities. You can even divide this 8 into 7, 1, 6, 2 and so on till 1, 7 as well. So there are a lot of possibilities for each of the item, right? So I hope you have understood the entire problem statement. Definitely going with the brute force approach is not the way to go, because each of the item can range from 1 to 10 to the power of 9. So there will be maximum of 10 to the power 9 possible ways to divide a given number, and so we cannot even do it for 2 or 3 items, because that will not be within our time limit range, isn't it? So let's look at an observation in order to build our solution. If you imagine an array with a size 8, 3, then in this case, if I ask you to divide this by using one operation, what will you do? Which one will you choose for division? That is my most important question, right? Which one to divide? As I explained earlier, that it always makes sense that if you want to minimize the maximum value, definitely you will not choose any other value, right? Greedily, it will always be optimal to pick the maximum value and divide it. Okay. So if you pick this 3 and divide it, then the max value of this array will not change, and therefore there is no benefit for us. But if you choose this 8 and divide, then only we can get benefit. But then this 8 has so many possible divisions, you see. You can divide it in 7, 1, 6, 2, 5, 3 and so on till 1, 7, isn't it? and all of these will fetch you different answers. In this case it will be 7, in this case it will be 6, and so on. Okay, in this case it will be 7 again. If you look at this example, in one operation it will be optimal to divide it into two equal parts. But this statement is not always true when the operations are more than one. If you look at the second example with the 10,3, there are two bags, and if we are allowed to do two divisions, if I pick the maximum 10 and divide it into two parts 5 and 5, and after this in the second operation I will pick the maximum and again divide it into two equal parts. Since integral division are allowed, therefore I will divide it into 2 and 3, not 2.5. okay, and this 5 will remain as it is. So in this case the answer will be 5. But if you had tried with a non-equal division where you had taken this 10 and divided it into 3,7 and again picked 7 in the next operation and divided into 4,3, then in this case the max of this entire final list is 4, and therefore 4 is a better answer as you compare with 5. Therefore you can say that you cannot always go for equal division when you pick an item. So deciding the size of the division is important. Dividing into half is not always optimal, and we will understand by the end of the video how should we actually do all these divisions, right? So I hope you understood this observation. Let's look at some extreme cases. In the extreme case, let's say that your array is 8,3. The number of operations allowed is infinite. It can be 10 to the power 9, let's say. I am required to do less than equals to the given max operations, right? I can do 0 operation or more operations, right? So if you keep dividing this 8, you will convert this into a run of ones. 8 times 1, you can write 8 times 1, and also this 3, you can write 3 times 1. So this final list, after this you will not be able to do any division because division below 1 is not allowed, and therefore the max of this list will be 1, therefore the answer is 1. So if the number of operations are more than the sum of the array, then the answer will always 1, right? If you look at the other extreme where the number of operation is only 1, then it will always be optimal to pick the maximum element of the array and divide it into two equal parts. Only when operations are more than 1, the division into two equal part may not always be optimal, right? But if it is only one operation, it will always be optimal, right? So don't you think that your final list's max value will always range in the range of 1 to maximum of the entire array which is given? When it will be 1, when the number of operations are infinite or too large, or it is greater than equals to the sum of the array. And when will you get the maximum of the entire initial array? When the number of operations are 0. That means we are not performing any operation. The max operation can be anything, but we can choose not to perform any operation, right? It is up to us. So this is the range in which our answer will actually vary, isn't it? Now once we have defined the range, let's say that our given array is again 8,3 and the number of operations are 2. If we follow an optimal path of division, then I can take this 8 and divide it into 5,3, and I can choose this 5 in the next turn and divide it into 2,3. After these two operations, the max of this will be equals to 3. Therefore, the answer in this case is 3, right? Now, if you think about it carefully, if I can use these two operations and divide it in such a way optimally that the maximum of the entire list is 3, then if I tell you that, okay, you know what, can we divide it in such a way where the maximum of the list will be equals to 4 or 5 or 6, can we do that? It will always be possible, because what we can do is we can just take this 8 and divide it into 4, 4, 3. Okay, this is the first operation, and then in the next operation take this 4 and divide it into 2, 2, and we will have another 4 left over, right? So in this case I was able to get the maximum of this list which is equals to 4. Now if I ask you, can you get a value 5 in the final result? Yes, it will always be possible, because I can divide it as a 5, 3, 3, and then take one of the 3 and just divide it into 1, 2 and 3, right? So I will always be able to get an answer 5, isn't it? So if you are able to get a result, that means in the final list after applying your operations, if you can get a result of maximum of the array as, let's say, 3, then you will always be able to produce an answer which is greater than 3. It will always be true. Therefore, if you imagine your answer to be the first tick in this entire list of answers, I already know that the list of answer will be ranging from 1 to the maximum of the initial array, as I had already mentioned, right? 1 to maximum of the initial array. So in this case, if I know that the answer is 3, then you can take any number which is larger than 3 and we can always get to that result. Our entire goal of the problem is to find the first tick, because if I take any lower value than this 3, then it is not going to work. Otherwise this 3 would not have been our answer, right? If 2 had worked, then 3 would not have been our answer. Then 2 would have been our answer. So this problem is asking about finding the first tick in the given array list. Fine. So I think you have already seen such problem. The exact same problem is the first VAT version from 278. It is an easy level problem because this array is already given, right? And a very similar assignment problem is capacity to ship packages within D days, which is from 1011 Leetcode number, right? So I hope you have understood that if you want to find out this first tick mark, you can go with a linear search from left to right, or you can apply binary search. In order to apply binary search, you can take this as low and this as high. And if any of this value is mid, let's say this value is mid, and if this is working for you, then you will save it in your answer. And your search region will always be on the left hand side. So you will update your high to mid -1 and again search it here. So if this is your new mid value and if this is not working, then you will always go to the right hand side, because none of the values on the left hand side is going to work, isn't it? So this will be your search area. This is your low, high and mid as well. And if you see this, it is working, and since this has a lower index than the answer, so this will be updated here, right? And finally your high will be equals to mid -1, and so low becomes greater than high. Therefore your answer will be the first tick in the given array. Okay, I hope you have understood this idea. Now let's see the binary search assignment problem solution for our given problem. In this given array 835, our max operation allowed is equals to 3. Now I know that the low value is 1 and the high value is the max of the given array, which is 8. I will always calculate the mid value by doing low plus high minus low by 2, so that there is no chance of integer overflow. I will assign the result is equals to integer max, which is infinity, because I want to minimize my result, isn't it? So let's start our mid value with a value of 1 plus 8 minus 1 by 2, which will be equals to 4. Okay. Now with this mid value, what I will try to do is I will try to iterate through all these array elements, and I will try to see that if I want to make all of these elements divided in such a way that it will always have a value less than equals to 4, then how many divisions are required? Let's see this. So if I want to divide this 8 to a number of bags, then how many bags will be produced? How many divisions do I need to do? I can just take this 8 and divide it by 4, and I will see that I will need 2 bags, isn't it? But what if our bag size was 9? Initial bag size was 9 and I had 4 as the divisor. Then in this case, if you do a direct division, it will give you 2, right? But it will not be 2, because it will be 4, 4, 1. It will be producing 3 bags. So therefore we have to take a seal over it, so that if there is some fractional part, then that means that a smaller number of items with a new bag will be created as well. So we have to always take the seal while doing the division. Once this seal concept is clear, the next thing is, if you have the value 8 and if you divide it by 4, then it will say that I need to do 2 parts. I need to make 2 parts. That means 2 divisions. So what you can do is whatever number of parts you get, either you subtract 1 from it to get the actual number of division, because if it was 12 and you were dividing by 4 and it said that 3 divisions, then actually you had to do 2 division. These are 3 parts, right? 3 parts means if you want to divide an element into 3 parts, you have to do 2 divisions over it, right? So either you subtract 1 value from the final divided part, or what you can do is you can just subtract this element, the divisor itself, and it will get adjusted. Okay, so this is the adjustment you need to make. So I have already written the formula here, that if you pick an operation and you want to divide it into a maximum size of the given mid value, then what you need to do is take the element, subtract the mid value from it and divide by mid. It is equals to, as I said, if you take the value 8 divided by 4, and whatever value you get, you just subtract by 1 and it will say 1 division, right? If you make 1 division over this line of size 8, then it will make 2 segments which will be having each of the value less than equals to 4. Again, if you had taken a size of 10 and you were taking the divisor as 4, then you were always taking the seal value, right? So it will say that 3 segments will be produced, where each of the segment will be of size less than equals to 4, right? So how many number of divisions do I need? I need to do 3 minus 1, that means 2 divisions. So if you take a line of size 10, divide it into 2 parts, then each of them will be of size less than equals to 4, right? I can say it will be 4, 4 and 2, right? So this is how the divisions will be done. I hope you have understood this. Let's try to see if I can get an answer value 4 with the given 3 number of operations. So what I need to do is I need to iterate through this entire array and find out how many divisions are required, how many operations are required. So if you look at this 8, then we will require 8 minus 4 by 4 seal of this, which will be equals to 1. So one operation is required to make it 4 and 4, right? If you look at this 3, then this 3 is actually already less than equals to 4, right? It has to be greater than 4 to apply your operation. Therefore, you should always check for the condition that the given element must be greater than the mid value that we are trying with. Otherwise, we will not be dividing it. So we will not do any operation for this. Again, for this 5, it will be 5 by 4, 5 minus 4 by 4 and seal of this. It will be 1. So I'll be doing one time operation to divide this. You can make it 4, 1 or 2, 3, whatever way you want to do it, right? So my goal is to just count the number of operations. In this case, the total number of operations required in order to make the final list where the maximum of the list will always be less than equals to 4 is 2 operations, and the maximum operations allowed are 3 operations. Therefore, can we get this answer 4? Yes, this answer 4 is working for us. Therefore, I want to minimize this result, so 4 will be overwriting this integer maximum. So this is how I will try to do the assignment. Now if 4 is working, then according to the previous concept, you already know that all the higher values will work. Let's try with the smaller value. So if you want to try with the smaller value, then definitely you need to update this high to mid minus 1. So we are doing these operations on integers. That is why I am doing mid minus 1. If it was floating value, then I will check for the precision and I may make 3.999 and something like that. Okay. Now when my high value is this, my mid value will get updated to a value 2. Okay, which is 1 plus 3 minus 1 by 2, it will be 2. Now if I have a mid value of let's say 2, I want to divide this entire array in such a way that my final list will have maximum value of 2. Can I do that? How many operations are required? So if you check out with this 8, you will require 8 minus 2 by 2 seal of this number of operations. So here you are requiring 3 operations, right? 3 operations to divide this 8, so that each of the segment must have less than equals to 2 size. For this 3, you will require 3 minus 2 by 2 seal of this, that means 1 operation. For this 5, you will require 5 minus 2 by 2 seal of this, that means 2 operations. So total number of operations here are 3 plus 1, 4 plus 2, 6. But the max operations allowed are 3. So you cannot get your final list with maximum value in the list being 2. So this is not working for us. So if this 2 is not working for us, I will always go to the right hand side and check for some higher value, right? So I will update my low to this mid plus 1, which will be 3. So in this case, low and high are same value. So the mid will also be the same value, which is 3. Let's check the assignment for 3. If you check for 3, how many operations do you want to do on this 8? So on this 8, I will do 8 minus 3 by 3. That means it will be 5 by 3 seal, which will be 2 operations. For this 3, I don't need to do any operation. So this will be 0 operation. For this 5, I want to do 5 minus 3 by 3. That means 1 operation. So total number of operations done are 3. Maximum operations are 3. So that means I can make a final list where the maximum of the list will not exceed this value 3. So in this case, 3 is working for us and 3 is smaller than 4. So let's update to 3. And now I will try to search for a lower value, because everything higher than 3 will work all the time. So I'll update this high to mid minus 1, which is 2. In this case, now the high has become lower than low value. So we will stop our binary search. And whatever is left over in the result is our answer, which is 3, right? So I hope you have understood this entire approach. In this case, we are doing binary search on the range of answer. Okay. So the range of answer is from 1 to 10 to the power of 9, as already mentioned in the constraint section, that each of the element is less than equals to 10 to the power of 9, and they are all positive values. Therefore, I will assume it with r, and so the binary search number of steps will be log r. For each of these mid value that we were trying, we were checking for all the elements in the array of size n. We were trying to find out how many operations are required to make the final list where the maximum of the list must be less than equals to mid. It was order of n because the number of items were n. Therefore, n will be multiplied with this log r, and that is why the time complexity is n log r. And the space complexity is order of 1 because we are not taking any extra space. Now let's look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, we are given the nums array and the max operations. I'll find the size of the array, assign the low with 1, the high with the max element of the array. I will take the mid value and the result assign it with infinity or the integer max value. Then I'll do binary search over the range. I'll always find the mid with low plus high minus low by 2 to avoid any kind of integer overflow. Then I will check if I can make a final list where the maximum of the list is always less than equals to the mid value. And how to do that? I just need to see the number of operations which will convert the given list, that means the nums array, into a final list where the maximum is less than equals to this given mid. And if the number of operations are actually less than equals to the max operations which are allowed, then I will return a true saying that yes, it is possible, otherwise it is not possible. And if it is possible, then all the values to the right of it will always be possible. So I need to check only on the left hand side if there is another true. I want to find the first tick mark. That is how I will do the adjustment of low and high, and I will break this loop if low becomes greater than high, and finally I will be returning the result. So I hope you have understood this entire code, and if you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.